Good afternoon, everyone. I'm Rong from the Chinese University of Hong Kong. Today, I will present our paper, Why It Happened, Identifying and Modeling the Reasons of the Happening of Social Events. This is a joint work with my supervisor, Cheng, and my classmate, Zhiyu. In today's presentation, first, I will talk about some backgrounds and challenges in modeling the event cascades, and then I will introduce some preliminary concepts used in our model. And next, I will propose our approach to model the event cascade, and next, I will talk about some event results and give a conclusion. In a nowadays social network, a huge volume of content is generated. As shown in the example, in Twitter, many tweets are posted every day. And the information which is carried by this content is diffused according to the user behaviors, as shown in the example. The information about the pet view is diffused according to the user behaviors. Thus, understanding the information diffusion process from the huge volume of user-generated content is important and the interesting research partners. Before the first discussing, let me introduce some basic concepts we use in this paper. We model the social network as a directed graph, and this graph contains two parts. The first part is a node set that represents users, and the second part is a node set, edge set represents user relationships. In addition, we denote a content set O, which indicates the content of in the social network. The content can be different via the different social network, such as ratings, tweets, and so on. And based on the definition, an event can be defined as a triple, which indicates user U adopts content O at time t. In this case, the adopting behavior depends on the social network and the content type. For example, maybe the writing reviews, give ratings, and so on. And based on definition of the event, we can define the event cascade as a temporally ordered sequence of events. And here is an example of the event cascade. From this observed data, we can easily track the following information about an event cascade. First, when a social event happens. Second, who has adopted a piece of content. And third, what content is diffused in the social network. However, there remains two essential questions. First, for a specific event, why does it happen? The second is, for whole event cascade, how does it form? And actually, answering how and why, these two questions, how and why, is very essential for us to understanding the nature of the information diffusion in the social network, and is very meaningful in the real applications. And there are many existing models try to model the event cascades, and we can classify it into two categories. First is the graph explanatory models. These models treat the social network structure as a strong prior for information diffusion. And another category is the graph predictive models. And these models ignore the social network structure and infer the implicit connections to explain the observed event cascade. And these models are all mainly focused on explain the event cascade as a whole, but they can't give a clear explanation of the happening of each event in the social networks, in the event cascade. And in order to answer these two questions, first, why it happened, we distinguish three influence factors which can cause the event happening in the social network. That is social influence, external influence, and intrinsic influence. These three factors provide the comprehensive mechanism to explain the happening of the social event. And in order to answer the second question, how it forms, we propose a generative probabilistic model, which aims to explain the emergence of each event in the social network and the formulation of the whole event cascade. And we call this model is the Combinational Mixed Poisson Process model. And next, I will first introduce three influence factors. First is the social influence. As all we know, the word-of-mouth phenomenon makes the information spread in the social communities, whether in the real social communities or the virtual social communities. And for example, if I post a tweet, and this tweet is very funny, and it would appear in my friend's timeline, and my friends will see it and retweet it. In this case, the information is diffused from me to my friend. And we call this kind of influence diffused through the social network, through the social connection, is a social influence. And here is the definition of the social influence. And next, according to the recent studies, the user in the social network cannot only receive the information through the social connections, but also through the out-of-network sources, such as TV stations, newspapers, and this out-of-network sources can influence everyone in the social network. We all will watching the TVs or browse the news websites, and these sources can lead to the emergence of an event in the social network, and we call this kind of influence is the external influence. And here is the definition of the external influence. Since we claim that the external influence can make the event happen, we choose the 3 example movies in Douban dataset and plot the number of rating events per day respectively. Here is the 3 curves. And from this figure, we can observe that a sudden peak appears among all 3 curves. And this sudden peak indicates an explosive growth of the rating events in the social network. Interestingly, we can find that the corresponding date of the sudden peak is exactly the premiere date of each movies. And as we know, it's obviously that the premiere of the movie is a very strong influence on the users. And thus, this corresponding relationship between the date of the sudden peak and the premiere date can show the strong signature that the external influence can make the event happen in the social networks. And other than the social networks and the external social influence and external influence, actually there exists another influence can make a social event happen. For example, if a user posts a tweet about action movies, and he may post a more tweet about action movies afterwards. In this case, the subsequent cascade of this user is neither triggered by the social influence or by the external influence. It's triggered by his own preference on the action movies. And we call this kind of influence is intrinsic influence. And here is the definition. And in order to validate the effect of the intrinsic influence, we also conduct data analysis on the real data, and we select 13 movies which is tagged with American cartoon and Japanese cartoon respectively, and draw the heat map for the average interval in days between the ratings of 2 movies by the same user. From this heat map, we can observe that, first, the average interval between 2 movies in the same category, that is this part, is much shorter than the different category. That is this part. And from this observation, we can see that the intrinsic influence can induce users to adopt content which is similar to his previous adopt content. Thus, the intrinsic influence can lead the event happen in the social influence, in the social networks. And based on the 3 kinds of influence, we assume that the whole event cascade is a unit of the sub-cascades triggered by the different kinds of influence. And for each sub-cascade, we can model the cascade by the Poisson process with the different intensity functions. Thus, we can propose our combinational mixed Poisson. We propose the combinational mixed Poisson process to generate the event cascade in the social network. This This process contains 3 Poisson processes, and we combine it with shared parameters, and the details is referred in the paper. And then, based on these models, we can write the intensity function for any user U adopting adopt tangent O at time t. And the definition is as follows. We can say that the lambda OUT is the sum of the 3 components. The first part is the social influence generated by users, which user U is followed and adopting the content O before time t. And the second part is the intrinsic influence, which is generated by all the historical events of the user U. And the second part is the external influence of the content O. And next, based on this definition, we can write likelihood. We can write the probability density function for any event. And therefore, for the observed event cascade, the joint probability density is a multiplication of every event in this cascade. And thus, we can write the log likelihood function for the observed event cascade in this form. And there is a parameter set theta contains different parameters to describe this model. And our target is to find the parameter set to maximize the log likelihood function of the observed event cascade. And in order to infer the parameters, we use the classification EM algorithm. And since it's very hard to infer the parameter directly from the likelihood function, we introduce a latent variable for each event to indicate the source event which make it happen. Thus, we can rewrite the intensity function for any event in this form, and the joint likelihood function with the latent variable set for the event cascade can be written in this form. And the classification EM algorithm contains 3 steps. The first step is E step. Given the current parameter set, we compute posterior distributions, and then we assign latent variables which provide the maximum posterior distributions of Formula 4. And next, in the M step, we estimate the parameter set theta. And next, I will show some experimental results. We conduct experiment on 2 real-world data sets, DOBA and Epinins. Here is some basic information of these 2 data sets and statistics of these 2 data sets. At first, I will introduce explanatory experiment on DOBA. We apply our model on DOBA data set to infer the reasons of happening of the event. Here is the overall result of the inferred result. This is the mean and the variance of percentage of each event type in the DOBA. And from this graph, we can observe that the variance of the intrinsic and the social influence is much larger than the external influence. This indicates that the diffusion pattern, the different diffusion pattern might exist among the different movies. And the second observation is the variance of external influence is very small. This indicates that the external influence on every user in this social network is stable for all movies. And since we see that there may exist different patterns of the diffusion of the event cascades, in order to inspect the details of the diffusion patterns, we conduct a case study for 4 movies. 2 of them are old movies and 2 of them are new movies. And here is some overall results of these 4 movies. The left is the number of the events and right is the event breakdown. And here is we then show the detailed event cascade structure of the 2 movies. For 2 old in this figure, each dot is represents event written event, and the different colors represent different event types. And if the event is triggered by others, there is a link connect between these 2 events. And from this figure, we can see that the user's intrinsic influence dominates in the diffusion process of the 2 movies. That indicates the user would like to watch or rate the old movies according to their own preference. And next is the event cut structure of the 2 new movies. And we can see that this is quite different from the two old movies. And the most event is triggered by the social influence. And the social influence dominates in diffusion process. This indicates that the user would likely to be influenced by his friends when he watching or rating the new movies. And another difference is that the event of the two new movies is much larger than that in the two old movies. The reason of this phenomenon is that the strong external social influence can make more social event happen in about two movies. And then we conduct a predictive experiment to our model. And the partner is event cascade prediction partner. We try to predict the further event cascade based on the observed event cascade. And we use MAP as an evaluation metric. And here is the result of our experiment. And we can say that our methods outperform the existing solutions in both data sets and under all cases. And this shows the prediction power of our model. And finally, there is the conclusion. In this work, we distinguish three factors which trigger information diffusion in social networks. This is the first work to take user intrinsic influence into consideration for modeling the information diffusion. And we propose a combinational model based on a mixed Poisson process to model an event cascade. We design a classification EM algorithm to infer the parameters of the model. And the extensive experiments on large real data sets prove the explanatory and the predictive power of our proposed model. Thank you.
Okay. Thank you. Are there any questions about this talk? Yes.
Very interesting talk. I would like to know, have you considered the relationship between among the three factors, right? For example, the external factor can affect the social factors, and the social factor may affect the intrinsic factors, right?
Oh, your
right.
question is
right, because here in your optimization, you consider three factors with different ways, right? So my question is, do you consider, do they have any relationship among these three factors?
Yes, they have a relationship among these factors. And in our paper, we model these three factors by some parameters. And for some parameters, the different factors may share the same parameters. And that means this parameter will influence these two factors. And actually, they are not independent in a real application, in a real sense. And we consider this and use a shared parameter to model it.
Okay. Any additional questions? All right. Let's thank the speaker again.